Hi everybody. So this is my second video on Pythagoras' theorem. In the last video I showed you how to calculate the hypotenuse. In this video we're going to look at finding a shorter length. And if you want to work along with me in this video, you can download this PDF from my website. I'll leave a link below. So if we begin with example 1, we've been given this right angled triangle and we need to work out the length A to C. And we're going to use Pythagoras' theorem. So if we draw a square on each of these sides, then the area of a square on A to C will have an area of A squared. So we're just multiplying this by itself. And the area of a square on this side will be A squared. And these two areas will have a total of the area on the side A to B, which will be 10 squared. So we can write this as A squared, this area, plus the 8 squared, which is this area, will have a total of 10 squared, which is the area on the side of a hypotenuse. Do you remember that the hypotenuse is the side which is opposite the right angle? This is always the longest length. And we can work out 8 squared as 64 and 10 squared as 100. So we get A squared plus the 64 will equal 100. And then we can subtract the 64 from both sides. And then these two will cancel, so we'll have A squared will be the 100, take away the 64, so this will be equal to 36. So that tells us that the area of a square on this side will be 36. And we can work out the length by taking the square root of this. When we square root both sides, the square root and the square will cancel. So A will have a length of 6 centimeters. Okay? So do you want to try and work out length B? You can pause the video, and when you come back, we'll go through a solution. Okay, so again, using Pythagoras' theorem, we've got the area of a square on the length A to C. This will be B squared. We'll add the area from A to B, which is 12 squared. And this will equal the area on the side B to C. So this will be 15 squared. We know 12 squared is 144, and 15 squared is 225. So if we take away the 144 from both sides, these two will cancel. So we'll get B squared will be 225, take away 144, which is 81. So the area of this square will be 81 centimeters squared. And then to find the length, we'll take the square root of 81. So B will equal 9 centimeters. How did you get on with that? Okay, let's try example 2. So with Pythagoras' theorem, we quite often get worded questions, and the key is always to draw the diagram. So do you want to read through question 2 and have a go at it yourself? And then you can check you're working with mine. Okay, so how did you get on with that? If we begin, we have the ground, and then a vertical wall, and then we're told that a ladder of length 3.3 meters rests against the wall. So we'll label this as 3.3. And the angle between the wall and the ground is at 90 degrees. And we're told that the ladder is 0.8 meters from a base of a wall, this length of 0.8. And we need to work out how high up the wall the ladder reaches. So that will be this distance here, and we'll call this h. So you can see we've got a right angle triangle with 3.3 meters, the length of a ladder. This is our hypotenuse because it's opposite the right angle. So to use Pythagoras' theorem, if we imagine a square on this side, this will have an area of 0.8 meters squared. and we'll have a square against the wall. This will have an area of h squared, and these will have a sum of the area on the ladder. So this will be 3.3 squared. So to work out h squared, we can take away the 0.8 squared from both sides. So h squared will be 3.3 squared minus the 0.8 squared. And then to work out h, we can take the square root of both sides. And then you can see the square and the square root will cancel. So we're left with h will be the square root of 3.3 squared minus the 0.8 squared. And I want to show you how we can work this out on our calculators. We'll press the square root button, and then we want 3.3 squared minus the 0.8 squared. And then we can convert this to a decimal. We'll press format, decimal. So the height of a ladder up the wall is 3.2 meters to 1 decimal place. Okay? Let's try example 3. So in this question, we've been given two right-angled triangles that are joined together. We've been asked to work out length C, given our answer in exact form. So do you want to give this question a go? Okay, so if we begin with the first right-angled triangle, the one in green, and then we can work out this hypotenuse. Once we have this length, we can use Pythagoras Theorem again with the blue triangle to work out the length C. So the first thing we need to do is to think about the hypotenuse on this green triangle. We've got a base of 5 and a height of 9. And if we call this hypotenuse x, from Pythagoras' theorem, we know 5 squared plus 9 squared will equal x squared. So 25 plus 81 will give us x squared. And this is 126. So we can work out x as the square root of this. Now, because we need to leave it in exact form, I'm going to leave this as our answer for the hypotenuse. And I'll write this on our diagram. Square root of 126. And now we have two lengths in this blue triangle. So if we apply Pythagoras' theorem again, the hypotenuse in the green forms the base in the blue. So this will have a length of root 126. And the height will be 4. So using Pythagoras' theorem, we know 4 squared plus the square root of 126 squared will give us the hypotenuse c squared. And when you take the square of this square root, these two will cancel. The 4 squared is 16 plus the 126. We can add these two together, so c squared will be 142. And then to leave it in exact form, c will equal the square root of 142. Okay? Centimeters. So let's try one more question. So in example 4, we've got a problem-solving type question where we need to work out the length d. Again, do you want to give this question a go? You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So the way we're going to do this, if we think about this smaller triangle, and we can work out this base, then we can use this length to find d in the larger red triangle. So we need to begin with this blue triangle. We have a perpendicular height of 8, and the hypotenuse is 10. So we can work out this base as the square root of 10 squared minus 8 squared. And this will give us 6. So this has a length of 6. And then if we draw the bigger red triangle, the perpendicular height is still 8, and the hypotenuse is now 16. But the base is now d plus the 6 we just worked out. Now we can apply Pythagoras' theorem again. We know the area of a square on the hypotenuse will be 16 squared, and this will equal the area of a square on the 8 side. So 8 squared plus the area of a square on the base, which will be d plus 6 all squared. And then we can subtract the 8 squared from both sides. Then these two will cancel, and 16 squared minus 8 squared is 192, plus 6 all squared. Then if we take the square root of both sides, the square and the square root will cancel, and the root of 192 is approximately 13.86, and this will be d plus 6. So to work out d, we'll take away 6 from both sides, these will cancel, and to 2 decimal places, we get approximately 7.86 centimeters. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.